Hello, my name is Aaron Lima. I'm a Principal Solutions Architect here at AWS. And in this session, Windows 3.02, we're going to talk about managing and governing Windows workloads on AWS. Many customers that I've worked with who are looking to bring their Windows workloads into AWS are considering lift and shift. They consider lift and shift because they've bought a lot of off-the-shelf applications and they want to bring it in just as is. Once they start to look at that, they're then concerned about day two operations, things such as monitoring, compliance, patching, or just configuration. And in this session, we'll cover how to manage and govern Windows workloads, as well as automating the setup of these components. And automation is crucial because it ensures a standardization across our environment. And in my case, make sure that you have a good work-life balance. So we're going to cover and talk about three specific services. We're going to give you an overview and then walk into a demo. The three services that we're going to cover is AWS Systems Manager, Cloudwatch, and CloudFormation. So first, let's talk about Systems Manager. Systems Manager is one of my favorite services inside of the AWS ecosystem because it's like the utility knife or Leatherman tool of services. There's so many features, and we're not going to cover all the features on this slide, but we're going to point out a few which we're going to talk about in our demo. The first is run command. Run command is the ability to remotely run PowerShell scripts against Windows instances or Windows workloads. And specifically, we're going to focus on the AWS Apply DSC Moth document that also helps us to get compliance information of our operating system. We're also going to take a look at Patch Manager. Patch Manager is the ability to set a patch baseline that we want our instances to comply to, and then also get compliance information as to whether our instances are at that baseline or not. All of these features are dependent on documents, and documents are the way that we can say what type of workflow we want to have, whether it be inside of the instance or across AWS services. And then automation is the service that we're going to use that's going to get triggered by EventBridge to ensure that all the components that we want are installed. And then inventory is the way that you can understand what type of software you have across your environment. And inventory is going to have an integration with License Manager where we can start to get an understanding of our license compliance. Cloudwatch. Now, Cloudwatch is a service that really focuses on gathering metrics and logs for our instances so we can make sure that they're healthy. And in this demo environment, we're going to install the Cloudwatch Agent and configure that Cloudwatch Agent using AWS Systems Manager. Now, one of the things to note about monitoring is that at AWS, we really focus on observability. And Cloudwatch gives you two of the three pillars of observability inside of AWS, which is metrics and logs. The third pillar is traces. So I encourage you to take a look at any of the sessions that take a look at AWS X-Ray and how can you use X-Ray inside of your applications to get the full observability of your application inside of AWS. And last is CloudFormation. CloudFormation is our service that's infrastructure as code that allows you to automate deployments of stacks inside of AWS. A CloudFormation template could be written in YAML or in JSON to be able to define your infrastructure and then submit it to the AWS CloudFormation API to deploy those in a parallel fashion for you, and also to maintain lifecycle of that stack. Now, we're going to take a look at the demo environment architecture very quickly so that you can understand what it's being deployed. So in the demo environment, we have a brand new VPC that's deployed by the CloudFormation stack. In that VPC, we're creating private as well as public subnets. In the public subnets, we'll have NAT gateways so that we can have egress traffic and outbound traffic. And then in the private subnet, we're going to create a auto-scaling group where we're going to deploy IIS with a static web page that we can test against. Now, the auto-scaling group is going to be configured with lifecycle hooks. Those lifecycle hooks are going to trigger Amazon EventBridge so that an automation workflow can get kicked off that will not only make sure that our instances are part of the Active Directory domain, but that they also have CloudWatch installed and that CloudWatch is configured to gather the logs and metrics that are important to us. Then that automation workflow is going to trigger back to lifecycle hooks that it's complete and put that instance in service. If that instance is terminated, there's going to be another event that will remove that instance from the domain. So this starts to show you in this quick start how you can do joining of the domain and removing from a domain using AWS services and a complete kind of life cycle of an instance. So with that, why don't we jump into our demo and take a look at what this looks like.
When building automation, you don't need to start from scratch. I used AWS Quick Starts to build the demo environment for this session. AWS Quick Starts can be found at aws.amazon.com/quickstart. And here on the left-hand side, you see that I've checked Microsoft. And this is filtered out to show the catalog of Microsoft Quick Starts. I've worked with a lot of customers that have started deploying their Windows workloads by looking at AWS Quick Starts. And the reason for that is because AWS Quick Starts are also open sourced. So if you would go to github.com/AWS-Quickstart, you would be able to see all of the projects that are listed on the landing page of the Quick Start team. These projects can be forked. You can submit pull requests to them, open up issues, and interact with the Quick Start team. Now, if I filter out here, what you can see is this quickstart-microsoft-IIS quick start. I've downloaded this and I've copied this to an S3 bucket in my account. So why don't we take a look at that real quick? So if I go to the S3 bucket of my account here, you'll see that I have the same quickstart-microsoft.IIS prefix name, and I'm in the templates folder. Now in the templates folder, there's a bunch of CloudFormation templates. One of them that I'm going to focus on is the IIS main template. So I'm going to go ahead and copy that object URL. Now, before I go to CloudFormation to deploy this, I'm going to go into VS Code and let's take a look at what that template looks like. Now, this template is a parent stack. And what you'll notice is that there's a bunch of other stacks that are deployed as part of this template. Now, every quick start includes this main template stack, which will deploy a VPC stack according to best practices, Active Directory, jump host via RD Gateway, and then finally our workload stack. So when you look in the repo and you look at the main template, you really might focus just on the workload template that deploys the workload in question, whether it be SQL or IIS. Here you see that I'm using the type of AWS : CloudFormation : stack, and I'm specifying a template URL, very similar to what I'm going to do in the console in a minute. And then I'm passing all of the templates, all of the parameters, sorry. So this kind of shows you a good example of how to do a nested stack configuration. And again, as I mentioned, a lot of customers come to these quick starts and they use it as a place to learn how to use CloudFormation or AWS System Manager automation. Now, let's go ahead and go to CloudFormation and deploy this in particular stack. Now, one of the things I want to just take a step back here is when I did create stack, you notice that there's stack with new resources, which I will select, but there's also create stack with existing resources. Now, if you were lifting and shifting workloads with Cloud Endure, and then you wanted to add them to a stack so that you can have lifecycle management, you can use this new option that was released by the CloudFormation team, existing resources. But for now, we're going to use with new resources. And I'm going to paste my template URL. And we're going to quickly walk through some of the parameters here. Now I'm going to name my stack because every stack has to be unique in the region, so I have to give it a unique stack name. And I'm going to select Managed AD. There's a drop-down option to also deploy AD on Amazon EC2 instances, but I'm going to stick with Managed AD. Keep all these domain names, DNS name, configuration the same, but obviously I have to specify a password. Now the password that's being captured here is being stored in Secrets Manager, and you can take a look at the repo and see how the scripts are retrieving a secret from Secrets Manager, and that'll be the same in the SQL Quick Start as well as the Active Directory Quick Start in IIS. Now in terms of self-managed Active Directory configuration, these are optional because I've selected Manage AD, but this is where I can specify the instance types, the NetBIOS names for those instance types, and the IP addresses. Here I'm going to select my key pair name. Now, here I'm using AWS Systems Manager that's installed in the Omnis as part of this quick start. So I really don't have to specify a key pair name because I'm also joining an Active Directory domain as I deploy this CloudFormation template. Also, because I have Systems Manager, I can use Session Manager secured by IAM roles to get into the instance as well. So key pair names are not required. So in an enterprise environment, if you don't want to start managing key pair names, you have other options. In terms of network configuration, I'm going to select 2 availability zones because I want to make sure that I have high availability in this case. And I'm going to keep all the VPC options for CIDR ranges the defaults. Under the remote desktop gateway configuration, this setting allow RDGW external access. I need to specify a CIDR range or an IP address that can connect to my RD gateway jump host. So I'm just going to specify the VPC for this, or the CIDR range for this VPC. I'm going to select a newer instance type in the T3 large. And for the auto-scaling group here, I'm really focused on high availability. So I'm going to keep the defaults at 2 for desired capacity and the group minimum size at 2, where it ensures that there's one instance in each one of the availability zones as part of the auto-scaling group. Now, auto-scaling groups can also be used to scale up and to scale down based upon a custom metric or a business metric that you can create in Cloudwatch. But in this case, we're really focused on just high availability. So you can customize these templates to suit your needs. In terms of the ALB schema, I'm going to keep internet facing, which means I also have to specify the CIDR range that can connect to those load balancers. Again, for the sake of kind of walking through these parameters, I'm just going to specify the VPC CIDR range of this VPC being deployed. I'm going to keep the instance types for the IIS servers the default. And instead of using an AWS Quick Start bucket, I'm going to specify my bucket here because this is where I have all the assets for this Quick Start. And so effectively, I've made this Quick Start my own. I'm going to go ahead and click Next. Now, one of the things I want to stop real quick, and again, just remember I'm doing this from the console, but you could do this via CLI or API. Under stack creation options, there's this option about rollback on failure. So CloudFormation, if it fails or if a stack fails to create, it's going to roll back all of the instances. So if you have an R5, it's not going to charge you. We want to make sure that we keep you at a lower cost if things fail. But if you want to keep those instances in order to troubleshoot them, you would disable the rollback on failure feature, and you could log into those instances and see what happened and what occurred with the automation. Now, using Systems Manager automation, we're also pumping those logs to CloudWatch, so you could definitely leave this enabled, but I just wanted to point this out to customers so that you understand what that does. I'm going to go ahead and select that I acknowledge that this is going to create some IAM roles and go ahead and create the stack. Now, as any really good cooking show, I've already baked this pie. So why don't we head over to the US West 1 region and take a look at this stack. So we see here that I have IIS, my VPC stack is deployed, my AD stack is deployed, my IIS stack is deployed, and I have all of my resources. Now, in terms of IIS in particular, it's broken up into multiple different stacks. This was done based upon customer feedback so that customers can take the pieces that were important to them, or inside of an organization when you have different teams that are managing different components, you can have them take a look at the stack, like for instance, security stack, that's going to be important and pertinent to them. Let's just take a look at the automation stack real quick. So I'm going to go back to VS Code, and I'm going to click on the automation parts template. Now here in the automation parts template, I have this resource type of AWS : SSM document. And what I'm creating here is an SSM automation document. This is the document that is triggered by the event bridge triggers from the lifecycle hook. Now, one of the things you'll note here under content is this is the actual document itself. And the schema version here is 0.3. This means that this is an automation document. Command documents and session documents have their own schema version number. Under assume role, you're also going to notice that I have this double curly braces in quotes option here with automation assume role. Now, if you look at the parameters, I have a parameter of the same name. So essentially what we're doing here in SSM automation, or in SSM in general, is that I'm doing a string replacement for this parameter right here. So it's going to make sure that it grabs whatever role I specify to run this automation workflow. And this can be used also in your code embedded in different steps, which we'll talk about in a second. But under the main steps section is the actual steps that this automation document is going to take. And it's going to take it in a linear fashion unless I specify conditional branching or I specify a different step once I've gone into a branch. You could take a look at the SQL Quick Start for conditional branching inside of an automation document. But in this automation document, we just have a couple of steps that are pretty simple to follow. You'll see that I'm using different action types in each one of these steps. So here I'm waiting for this AWS resource property, which is an instance or the instance ID that I pass, to be running. So this is going to basically loop until, or kind of pause until this can confirm that this instance is running, and then I'll go to the next step. And the next step, I'm using the AWS assert resource property type, which is basically validating that this instance is running before I actually run any commands against it. Here you'll notice that I'm now running a different action type. This action type is probably the most common that you'll use, which is AWS run command. This will submit run command documents against instances that you are targeting. In this step, I'm using the AWS run PowerShell script document, which means that any embedded PowerShell that I have in this step will get executed. So we see here that I have some embedded PowerShell, which is essentially creating a new instance tag on this instance. Another thing to note in this step is I have on failure. So I can specify failure actions. In this case, I'm going to signal lifecycle hooks that we want to abandon this hook. Now, what's important about quick starts, again, because they're open source, you can copy this section and then modify it to suit your needs. In other words, maybe you have a PowerShell script that you already run against a set of instances to perform configuration. You can just plop that right in here and continue to use AWS Systems Manager Automation to execute that against instances in AWS or on premises. Now that we've kind of looked at the step configuration, let's just jump into Systems Manager in the console and see what this looks like from an executed perspective. So here I am in AWS Systems Manager in the region. I'm going to click on Automation. And in Automation, we see that I have this automation document has ran successfully. Now, if I click into the execution ID, we can take a look at each one of the steps that I just kind of walked through in VS Code. So we have the assert and the wait for resource property types and the run command that's happening here. Now at our outset, we said that we wanted to make sure that we wanted to monitor this instance. So here I'm installing the Cloudwatch agent and I'm configuring this Cloudwatch agent to not only collect IIS logs, system logs, but also metrics such as memory or free disk space. I'm also making sure that this instance is joined to the domain and I'm configuring IIS to my specified standard. Now, if I click into one of these steps, I can also get more information. So here I have a truncated output of the actual standard out that happened on the instance in PowerShell. Each one of these logs are also being piped to CloudWatch logs. So I can take a look and search through it and use CloudWatch Insights to see different errors that happened inside of or successes that have happened as each one of these steps ran. Now, if I go back to the execution ID, let's take a look at the last action type here, which is AWS Execute Aws Api. Now here, I can execute any AWS API natively. In this case, I'm signaling back to lifecycle hooks that I've completed the configuration actions and the instance can actually go into service. So this starts to show that you can use SSM automation as a low-code or no-code solution to do configuration management inside of your estate using AWS Systems Manager. Now that we've specified that we've installed this CloudWatch Agent and we've configured it, why don't we go and take a look at what that actually looks like in CloudWatch. So let me go here in CloudWatch real quick. Open this up in another tab. So if I go to CloudWatch logs and take a look at the log groups, we'll see here at the bottom that I have IIS logs and have system logs. If I click into IIS logs, I'm collecting each one of these instances. And here's the actual IIS log output for each one of those instances, right? So if I want to take a look at what's happening, we see that the ELB is running health checks against these instances. But I can also take a look at metrics. So if I click into metrics and then click into the CloudWatch agent and click under host and instance object name, I can take a look at the logical disk space of these instances. And if I go back one, I can also click into the memory. So here we can start to get an idea of memory and local disk usage. I can create a dashboard. And again, I can, in CloudWatch, collect two of the pillars of observability, which is metrics and logs. Now, what about our patch compliance information? Well, one of the things that I've done in that repo is I've also included a CloudFormation template that actually sets up some of the patch management so you can see what that would look like from a CloudFormation perspective. One of the things that I'm creating is a resource group, and resource groups are a very powerful construct inside of AWS Systems Manager. This allows grouping of instances or different AWS resources so that you can target operational tasks against them. So in this CloudFormation template, I'm creating a resource group. I'm also creating a custom patch baseline. In AWS Systems Manager, there's a default patch baseline, which has critical security patches or critical updates that are pre-approved in 7 days. But if you wanted to create your own patch baseline, you can take a look at this CloudFormation resource. I'm also creating a maintenance window as part of this resource, a target resource group, and a set of target resource actions. So this will basically run this AWS run patch baseline against my instances and run it with the install operation on the third Saturday of every month. This is basically what this CloudFormation template is going to do. But one of the things I want to show real quick is we want to get this scan patch information and compliance very quickly. I'm actually going to use the AWS SSM association resource type, and I'm using the wait for success timeout in seconds. So what this parameter actually does is that when I run this CloudFormation template, it's going to cause CloudFormation to wait until SSM has run this run patch baseline against my target instances, and then complete once that's been done. So in this case, I'm running a scan operation, which will allow me to get the patch information for the instances that are deployed as part of my workload. So why don't we go to CloudFormation, and run this stack. So I'm going to go ahead and create a new stack with new resources. This time, since I have it locally, I'm going to point to my local location, and I'm going to call this stack patch management. Now, as part of the resource group creation, I have to specify a resource group key. So in this case, I've defaulted it to ASG name, which is a tag that I've put on each one of the IIS instances. In terms of the value, I'm going to give it the autoscaling group name value. This will create my resource group. In terms of patch baselines, I'm going to set my patch baseline to approve after 14 days, just because I want to be a little different. And I'm going to call it my custom patch baseline. In terms of the patch baseline patch group name, I'm going to set it to IIS boxes. So when I create a patch baseline, I want to associate it to a patch group, and the patch group has to have a tag called patch space group, and then the value can be whatever you specify. So in this case, it's going to be IIS boxes. And I'm going to keep this patch baseline for Windows Server 2019 because that's what all of my IIS servers are. Hit next, and we'll go ahead and create this stack. So as this stack is creating, we'll just pause for a moment. So now my stack is completed. And if we take a look at the events, we can see that I ran the scan for patches. So why don't we go back to AWS Systems Manager to see what this CloudFormation template did. Now, if I go click on compliance, one of the things that we'll see is that there's a bunch of compliance information for my instances. Because I've ran the scan for patches, I have patch compliance information. And if I click here, it was targeted against my 2 IIS boxes. If I click into the IIS box itself, one of the things you'll note is the patches that I have installed. I have that information. Now, if I go back to compliance, we'll also note that I have, because I'm using the AWS apply DSC MOF document and PowerShell DSC, I also can get information of the compliance of my operating system to my configuration that I expect. So we see that I have 2 compliant resources and I have 2 non-compliant resources. So if I go back into this instance in question, I'm under patch, but if I go to configuration compliance, I can also get the information of what's not compliant on this instance. So we see here that my website configuration and that the website files are not on this box. Now, if I rerun this configuration, I can get to see if this is still compliant or get more compliance information. But this starts to show you the power of being able to use PowerShell DSC with AWS Systems Manager to get compliance information and my configuration compliance information inside my environment. So now we have patch information and to see whether we're patch compliant. We also have configuration compliance information. But as we know, as many Microsoft customers worry about, is licensing. So why don't we take a real quick look at License Manager. So I'm going to go here and just search for License Manager. And AWS License Manager is a free service that can help customers understand their license compliance inside of AWS. So here I'm going to create a license configuration file for SQL 2019 because as you saw, I deployed the SQL Quick Start as well, downloading SQL and installing it. So this is not using licensed DOMIs. So I'm going to go ahead and say the license type is by vCPU core, and I'm going to say that I have about 50 vCPU licenses. I'm not going to enforce the license limit, but I can, which will prevent RDS instances or instance launches from occurring, and it'll check against the license configuration. I'm going to head and select SQL Server as my product name and 2019 as my SQL Server product type. And here I'm going to check don't track licenses included in the instance. So anything that has AWS provided licenses, I don't want to know about. I'm going to head and click submit. And now I have this license configuration. If I go to search inventory, we see that I have a bunch of instances that are deployed in this region. So I'm going to go ahead and select all those instances and associate that license configuration with it. Now that I've associated this license configuration, I can go to the dashboard and we see that I'm compliant to my SQL licensing stance. And I have 12 additional licenses that I can deploy. So this starts to show you how using License Manager, you can get your compliance configuration for licensing information as well. So far we covered license compliance, patch compliance, and also collecting and monitoring our Windows workloads. Why don't we go back and do a run command using resource groups. So let's go back to Systems Manager. And I'm going to click on Run Command. And I'm going to click on running a command, and I'm going to select the AWS Run PowerShell document. Select that there. And so this, I'm just going to run a get Windows features with the where installed option in the command. And I'm going to select my resource group that we created as part of our CloudFormation template. So here we see my IIS demo stack is being created. And I'm going to go ahead and enable CloudWatch log. So this is going to push the CloudWatch log and run this command. And we see that the two instances that are part of my IIS stack, because I've specified them in the resource group, automatically get targeted to run this command against. And we see that one already ran successfully. Now, finally, I want to show you how to set up application insight. So if I go back to CloudWatch, there's a feature in CloudWatch that allows you to configure metrics, logs, and alarms for the applications that you're running. And in this case, because I'm using IIS, I want to go ahead and configure this. So let's go to View. And this is under Settings under CloudWatch. I'm going to click Get Started. And because I have a resource group configured, I can just go ahead and specify that and hit Next. I could also configure application insights, which does use machine learning to report back on metrics and monitoring via CloudFormation as well. So here I'm going to say that the application tier is going to be an IIS web front end. Click Next. Again, it's going to go ahead and also configure collection of log groups and log types. And if I click Submit, this is going to go ahead and you'll see that I've already created a somewhat of a dashboard here. It grabs a component, which is the application load balancer and all the IIS servers behind it. And this will use machine learning and monitoring of best practices against this IIS stack. So this is under Settings in CloudWatch, and then you would click on Application Insight. Okay, so now we've showed you compliance, monitoring. You can also set up X-Ray here, but we kind of showed you a bunch of stuff using CloudFormation to deploy this workload inside of AWS. So what I hope to encourage you to do is hopefully you can go to that GitHub repo, take a look at all those CloudFormation templates, and get familiar with each one of these services so that you can manage your Windows workloads inside of AWS.
Well, I hope you found that demo to be informative and useful. Now, one of the services that we didn't cover as part of our demo environment is AWS Config. And the reason why I want to mention it is because while we were focused on a lot of the compliance inside of the operating system, AWS Config is a service that focuses on the instances and the AWS resources. So if you want to get compliance information on whether those instances have the right security group enabled or whether they have open access security groups, AWS Config is a service that you'll want to take a look into. And I also want to leave you with a bunch of links. I'm a very big believer of giving links and assets so that you can have a place to start after this demonstration and after this session. The links here are pointing to the quick start that we used as part of this session. It also has a link to samples that show how to use CloudFormation and AWS Systems Manager together. A link to our workshop that demonstrates all of the management tools and has different kind of walkthroughs and tutorials that you can take to see how you can manage your workloads inside of AWS. And the last two are tutorials for Application Insights, which is the service that we mentioned at the tail end there that can help you get best practices around monitoring not only SQL, but also IIS and .NET applications. So with that, I want to thank you for attending this session. Again, I hope you found it to be informative and helpful. And please, as always, don't forget to complete the survey so that I can have feedback to become better. Thank you very much and have a great day.